Now we are going to discuss the lecture. Okay. So before going to discuss about of the today class, just we will remind the last class, that is effect of gyroscopic couple on a naval ship. So all of you observe that naval ship point of view. So here three types of effects are occurring in naval ship. Those are the steering effect and pitching effect and okay, rolling effect. So all of you observe that. So here
Sir looking
steering
smart
point
today.
of view already.
Sir,
Oh,
keep
listen,
it
listen,
sir.
guys. Steering point of view. Okay, steering point of view. What we discuss conditions as follows on our naval ship during the steering effect. So already we discussed that, and just we will remind the one condition. So all of you observe that. So okay, is it visible my screen? All of you? Is it visible?
Yes, sir.
Okay.
Sir, fit to base button, sir.
Okay, I will make it. Okay, okay.
Lal.
Then we can see clearly. L310.
So all of you observe that.
370.
So observe the diagram. Okay, guys, please please mute your mics, all of you. So
Dinesh.
naval ship, all of you observe that. Naval ship taking a left turn. First condition, all of you observe that the rotor rotates clockwise direction when weaving from the weaving direction is, all of you observe that weaving direction, this is here stern, when weaving from the stern, and the rotor rotates clockwise direction, clockwise, all of you observe that clockwise direction, and the ship will steers to the left turn. So the ship will takes to the left turn. So left turn is there. So when we observe that, okay, and the ship will steers to the left, then the effect of gyroscopic couple is, okay, to raise the bow, all of you observe that, okay, to raise the bow and lower the stern. So that is the our effect is there. So raise the bow, that means when it is taken to be left turn, so then the front portion, that is calling as bow portion. So that is, okay, that is rising, and back portion or stern is lowered the stern. So that is the first condition. If you are observing here, what I, okay, what I draw here, that is the annotations, through annotations, all of you observe that. So our rotor rotating clockwise direction and taking the turning movement is left side. So both are, if you are observing that, okay, opposite. When you are having that, then okay, the bow portion is going to be rise and stern portion is going to be lower. And similar to take the same condition and the ship steers to the right. So when we take the, okay, right turn, so if you are observing here, so both are equal. Okay, that means rotating in the same direction. So when both are rotating in the same direction, okay, turning movement is also will be the same. So then, okay, lower the bow and rise the stern. Front portion, the front portion is going to be lower, and back portion or, okay, stern portion is going to be raised. Okay, so those are the conditions. Similarly, to take the our next time we may also take the conditions, that is the anti-clockwise. When we take the anti-clockwise direction and the ship steers to the left, and anti-clockwise direction and the ship steers to the right turn. So that is how we get that. So those are simply to observe by the help of our vector diagrams also. Okay, if you are taken to be OX, just OX is the axis of spin. For example, if you are taking to that, so X is the our, okay, X is considered as the our front portion and O is the considered as the stern portion. Okay, that means bow portion and our stern portion. Then when we are getting the angular momentum left turn, so that is the our angular displacement. When we get that, so then X will changes to the X dash. That means our bow is going to be rise, and the lower the stern portion. Stern is lowered. And similarly to take the steering to the right. So all of you observe that. So OX is there. And when we take the right turn, then front portion, that means that the bow is going to be lower and the stern is going to be raised. So those are also watched in our vector diagrams also. Is it clear?
Yes, sir.
Okay. So now we are going to discuss about of the one problem belongs to the our naval ship. So all of you observe that it is a big problem. It's 14 marks problem. So all of you observe that. All of you observe that. So all of you just you will take the notes and okay, write a problem. That is that just you will mention the given data. What we have given in our problem. Just all of you mention. So all of you see that given data, a ship is propelled by a turbine rotor having a mass of 6 tons and speed of 2400 rpm. Okay, and the direction of rotation of the rotor is clockwise when viewed from the stern. The radius of gyration is 450 mm. Determine the gyroscopic effect when three conditions. What are the effects are there? Three effects are there. Those three are given here. So that's why it is going to be large. So that is the first one. Ship steers to the left in a curve of 60-meter radius at a speed of 18 knots. All of you observe that. The speed value will be given in knots. K-N-O-T-S. Knots. Okay, and the second condition, ship pitches 7.5 degrees above and below the normal position. The bow is descending. Then you will find out the maximum velocity and the maximum velocity with the pitching motion is SHM with a 18 seconds of time. And the third condition, ship rolls at the instant and its angular velocity is 0.0535 radian per second, counterclockwise when viewed from the stern. Also find the maximum angular acceleration during pitching. So the determining values are also more if you are observing the problem. So now we will write we will write the our given data. Mass is there. Mass is 6 tons. 6 tons of rotor is there. So that is the 6000 kg, that is converted into kgs. 6000 kg is there. Speed value 2400 rpm and radius of gyration 450 mm. Okay, that means 0.45 meters. And radius of curvature. So radius of curvature is here 60 meter. 60. And velocity of the vehicle. So that is the ship. 18 knots. 1 knot equals to how many kilometers? Anyone respond? 1 knot equals to 1.86 kilometers. Okay, 1.86. So that
1
means
mile.
18 into 1.86. That is again converted into meters. So 1860 meters divided by, it is also converted seconds. So 3600. Okay. So then simply to get the V value in meter per seconds, that is the 9.3 meter per seconds. And the pi value will be given 7.5 degrees. Okay, 7.5 degrees. And time period is there for SHM, that is the 18 seconds. And when the ship is getting to be rolling, so then the omega p roll value is there 0.035 radian per seconds. Those are the given values. Okay, the values were given. The values were given in our problem. So now coming to take the determining values. What are the determining values are there? That is the our gyroscopic couple during the steering value is there. That is the C value is required. And at the pitching, C max is also required. And alpha max. So that is the angular acceleration is also asking. Okay. And C rolls. So those are the determining values are there. Now going to take the given values are there, determining values already there. So now going to Okay, take the our formulas. What are the formulas used in our problem? So generally write here. So that is the C equals to I omega omega P and C max equals to I omega omega P. Okay, C equals to I omega omega P. So and alpha max angular acceleration formula is also there in our previous derivation, that is the pi into omega 1 square. Okay, those are the proceeding steps. Now going to next one, substitution or solution mode. So before going to calculate these determining values, some values are required. Those are the I value. So that is the mk square, mass moment of inertia. Mk square is there. So m is there and k is there. So just simply to find out the value. Okay. If you are having the calculator, scientific calculators, then simply to calculate the value. So that is the 6000 into 0.45 square is there. Then the value is 1215 kg meter square. And omega means n is there. So when we are having the n value and simply to find out the omega. So that is the angular velocity of our rotor. So that is the omega equals to 2 pi n by 60 and the value will comes nearly 253.6. And omega point of view, omega p during the steering end. Okay, it is belongs to during the steering. Then the omega p. So omega p means angular velocity of precision. So omega p equals to, what is the formula? V by capital R. V means V already there 9.3 and capital R means 60 radius of curvature 60 meters. So 9.3 by 60. So then the value nearly comes 0.155 radian per seconds. Okay, and pi value. So when we are having the pi value, that is given in terms of radians. Sorry. So that will be converted into, when we are substituting the pi value, first converted into that value converted into radians. So how it will be converted into radians? Simply to multiply the pi by 180. Do you understand the particular step? Okay, all of you observe that. Okay, so pi equals to 7.5 into pi by 180. So then the value comes 0.132 radians. Okay, this is the very important. Pi value generally given degrees, but that is converted into radians. So that is our multiplying with the pi by 180. So then the value is, hello, please mute your mics, all of you. So 7.5 into pi by 180, then the value is 0.132. Now coming to the omega 1, angular velocity of SHM. So this is the this is generally have at the pitching effect. Omega 1 equals to 2 pi by TP. So 2 pi means already pi value already know that 2 pi by TP time period is 18 seconds already given in our problem. So time period. Okay. Then the value comes nearly 0.35 to radian per seconds. Now, okay, going to find out our determining values. That is the C equals to I omega omega P. Just, okay, you will substitute the values. I value, and omega value and omega P value. Hello. Hello students, someone okay, unmute your mic. So please mute your mics. Please mute your mics. So now all of you observe that. C equals to I omega omega P. So I value is there 1215 and omega is the 253.6 and omega P is 0.155. So when we are substituting the all the values, then simply to get the our value, that is the gyroscopic couple during the steering. So that is the 47,759 Newton meter. 47,759 Newton meter. And now C max during the pitching. During the pitching, you will find out the gyroscopic couple at the maximum. So that is the I omega P max. Okay, all of you observe that. C max means I omega P max. So here all of you observe that I value already there and omega is there, but omega P max is not there. Omega P max. So what is the formula for omega P max? So that is the, okay, all of you observe that. So here we are not giving that. Just I will also write here omega P max equals to, formula is pi into omega 1. That is the formula, sir. Students, all of you observe that. Already I have written the one formula belongs to the omega P max. Omega P is different, omega P max is different. Why? Because omega P belongs to the during the steering effect, omega P max during the pitching effect. So omega P max means pi into omega 1. So pi is there and omega 1 is there. Both are multiplied. That value will be substituted here. So then P max equals to I omega P max. That value, okay, when you are calculating the particular value, nearly to come 14326.6 Newton meters. Okay, when you are calculating the particular terms, okay, it is not exactly to come. Sometimes we may also some difference, okay, but it may also have just you will get the appropriate values, not exactly. Okay, so don't worry about of exact values. So just you may get the particular procedure and the nearest values enough. So that is the C max. And now going to take the alpha max. That is the angular acceleration. Maximum angular acceleration. That formula is pi omega 1 square. Pi omega 1 square. Pi value already there 0.132 and omega 1 0.352. So that is when we substituted the particular, okay, those two values in this formula, then simply to get the alpha max. That is the 0.016 radian per second square. That is the our angular acceleration. Angular acceleration. All of you observe that. Angular acceleration during the pitching. Maximum. And now going to take the last one, that is the rolling effect. When we get the rolling effect, then find out the our, okay, gyroscopic couple. So all of you observe that it may also near a similar formula, but the smallest amendment is there. I omega P. But here I is there 1215 and omega 253.6. But omega P means this omega P belongs to the rolling value. So that is the our omega P rolls is there 0.035. Just you will write the particular value 0.035. Then simply to get the our gyroscopic couple during the rolling, that is the 10784 Newton meter. Okay, so these are the results also. So C is there, C max is there, alpha max is there, and C rolling is also there. Okay, all of you copy the matter. Okay, just copy the matter in your notebooks. It is very important problem, belongs to the naval ship. Am I give that? Am I giving the timing? Okay. Am I give the time or not? Just go to the next topic. Anyone respond?
Give me time, sir.
Please respond. Okay. 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 Just copy the matter. It is very important problem.
Sir, problem note cheyaledu sir.
Okay, it's not necessary. Why? Because already I sent to you the total PDF.
Okay sir.
Okay, sir. Okay, sir.
Do you understand the problem? Any doubts belongs to the particular problem?
No, sir.
Hello sir.
Tell me, ma.
C rolling lo omega p value ఒకసారి చెప్పండి సార్.
Omega p rolls. So that value already given in our problem. Okay. So here, if you are observing the total problem, okay. So those all are followed by the same formula, single formula. That is the I omega omega p. But the smallest amendment is there. That is the omega p value. So that is the angular velocity of precision. During the steering is different. During the pitching is different. During the rolling is different. Okay, that is the amendment is there in our entire problem. Okay, so during the steering we will find out through the formula is okay, through the formula of v by r, v by capital R during the
Omega
steering.
p sir.
And okay, during the pitching already I said that pi omega 1,
Sir.
and during the rolling already given in our problem. So those are the okay, that is the only amendment in our problem, in our gyroscopic couple.
Okay sir. Okay sir.
వెళ్ళేటప్పుడు ప్రదక్షిణ చేస్తాం కదా, ఆ వెనక భాగం వరకు తాకూడదు. వెనక్కి దండం పెట్టుకుంటాం కదా గుడికి.
Hello, all of you please mute your mics.
అది తాకూడదు.
315 lateral entry 315
దేవుడి దర్శనం
raise their hand. So please okay, please unmute their mic and ask me any doubt. Okay, number 376 is there. Roll number 376. Please take the attendance today. Okay, present is
Okay, sir.
Sriman Narayana. Raise their hand. Please ask your doubt.
మైక్ ఆఫ్ చేశారు.
Hello, roll number 387. Raise their hand. Please ask your doubt.
Right to question, sir.
Tell me.
One skip question, sir. We'll take screenshot.
Okay.
Okay, sir. Okay, sir.
Are you completed? Now going to move on next lecture. That is our next topic. All of you listen. Stability of a four-wheel drive moving in a curved path. So now going to take the four-wheel vehicle. So here all of you observe that consider a four-wheel vehicle, that is the wheels will be considered as the ABCD of a automobile locomotive, and it will takes to the turning towards the left as shown in figure.
మైక్ ఆఫ్ చేయమని చెప్పి ఫోన్ చేసి
Okay, please come. Now here the A and C are the inner wheels and B and D are the outer wheels. Okay, so all of you observe that. So here all of you observe that before going to derive the particular derivation, we may also know the some symbol represent some symbol notations. Those are the M. Small m is the mass of the vehicle, and small w is the weight of the vehicle, and small r suffix w is the radius of the wheel, and capital R is the radius of curvature, and small h is the height of center of gravity, and here I suffix w mass moment of inertia of the wheel, and I suffix e mass moment of inertia of the engine, and omega suffix w angular velocity of the wheel, and omega suffix e angular velocity of the engine. So here gear ratio is additionally to added that in this derivation, that is the gear ratio equals to omega suffix e by omega suffix w, omega suffix e by omega suffix w. All of you have to do that. And v equals to linear velocity of the vehicle, linear velocity, v equals to linear velocity of the vehicle. So linear velocity of the vehicle. So here you will observe that a little consideration will show that, okay, a little consideration will show that the weight of the vehicle W will be equally to distributed over the four wheels. So what is the, okay, what is the weight is there of our total vehicle? Okay, just all of you observe that it is a, okay, four-wheel vehicle is there. The total weight, okay, is shared with the four wheels, the total weight. So the total weight is sharing with the our four wheels. So four-wheel weight. So that is the how much? Actually the total weight is W, And when we are distributing the total wheels, then each wheel will get the W by 4. So similarly to write that mg by 4. W means mg by 4. Now here all of you observe that. Let us now consider the effect of gyroscopic couple and centrifugal couple. So before derivation only to calculate the gyroscopic couple effect. But here when we take the roadway vehicles, two types of effects are there. Those are the gyroscopic couple effect and second one is the centrifugal couple effect. Two effects. One is the gyroscopic couple effect and second one is the centrifugal couple effect. So now coming to the gyroscopic couple effect. So first we will consider the gyroscopic couple effect. Here all of you observe that. So you know that velocity of precision, angular velocity of precision, already know the formula. So that is the omega suffix p equals to v by capital R. V by capital R. Now here when we write the gyroscopic couple, okay, due to the four wheels and here all of you observe that. Coming to the four-wheel vehicle, so here in our before derivation naval ship point of view and our aeroplane point of view, only we should consider the propeller and propeller shaft. Only major concentration is okay to be focused on. Major concentration is focused on only propeller and propeller shaft. But here in our four-wheel vehicle point of view, roadway vehicles, four-wheel vehicles point of view, so those are the wheels are there. So how many wheels are there? Four wheels are there. So first we will write the gyroscopic couple due to the four wheels. So that value is okay, c suffix w equals to all of you observe that c suffix w equals to okay 4 into I suffix w and omega suffix w and omega suffix p. It is the same formula I omega omega p, but the smallest amendment is there. That is the how many wheels are there? Four wheels are there. So just multiplying with the okay, just multiplying with the 4. So that is the 4 into and moment of inertia point of view. Two types of moments of inertia are there. Those are the moment of inertia of the engine one and moment of inertia of the wheel. Two inertias are there. So those are the here consideration of moment of inertia of the wheel. So that is the I suffix w and moment of inertia of the okay sorry and angular velocity of the wheel. So that is the omega suffix w. Again angular velocity is also 2. Those are the wheel point of view and engine point of view. So here this is the consideration of only wheels. So 4 into I suffix w omega suffix w into omega suffix p. Omega suffix means p means general. That is okay v by r capital R. So let us consider that this is the our wheels. And now another gyroscopic couple. So that is the due to engine point of view, they may also write that. So that is the gyroscopic couple due to engine. C suffix e equals to only one engine is there. Okay, entire engine. Just you will write the entire engine of the gyroscopic couple. So that is the I suffix e omega suffix e omega suffix p. Okay, all of you observe that. I suffix e means moment of inertia of engine. Omega suffix e means angular velocity of engine, and omega suffix p means angular velocity of precision. It will be the same for the both. Okay, and now here net gyroscopic couple. Why? Because wheels point of view is one is there and engine point of view another one is there. So now going to calculate the net gyroscopic couple. So when we write that, so here that is the CW plus or minus C suffix E. CW plus or minus C suffix E. So that is when we write that, so the first one, okay, gyroscopic couple due to four wheels plus or minus gyroscopic couple due to engine. So when we write that, here common terms are taken out from the entire equation. Those are the, all of you observe that 4 into I suffix W omega suffix W omega suffix P. Okay, it is similarly to write the okay above one. And next one, all of you observe that I suffix E into omega suffix E is replacing with the term. Omega suffix E is replacing with the term. Which term is replaced with that? Okay, all of you observe that. Gear ratio. omega suffix, okay, G equals to omega suffix E by omega suffix W. So now omega suffix E means G into omega suffix W. So that is replacing here. And omega P will be the same. So now here some common terms are there in our equation. So those are taken out from the equation. So that is the omega suffix W into omega suffix P into the other terms are 4 into I suffix W plus or minus G into I suffix E. Okay, G into I suffix E. So that is the our net gyroscopic couple due to, okay, net gyroscopic couple due to the our vehicle. So now all of you observe that why are taken to be positive, okay, plus or minus here. Why? Because so wheels direction and the engine direction, when both are equal, that means the wheels are rotating the clockwise direction and the engine parts, okay, shaft and engine parts, what are the parts are there, those parts are also making the same sense of rotation, okay, clockwise, then simply to take it as the positive. Sometimes it may also taken to be negative when, for example, sometimes the vehicle will also taken to be reverse. So that time you may also consider the negative. That means, okay, wheels direction and the our engine parts directions are different. When we are taken to be different, then negative will be considered here. So that's why we are mentioned the plus or minus. The sign conversion is plus or minus. And now coming to the here, it is not too over. So next one step is there, that is the let us magnitude of this reaction at the two outer and inner wheels be the p newtons. All of you observe that magnitude of the reaction at the two outer and inner wheels. So all of you observe the particular, okay, our car, okay. So here four wheels are there. In this, only outer wheels, these are considered as the inner and these are the outer. So these outer and inner wheels will be considered as the, okay, let us consider the magnitude of this reaction force of the outer wheels and the inner wheels be p newtons. So that means outer wheels are 2, sorry, inner wheels are 2 and outer wheels are 2. So both are getting the only p newton. So then px equals to, now they may also write that, okay, couple means simply to write that force into distance, that is the p into x equals to couple c. P into x equals to c. So that equals to p equals to c by x. P equals to c by x. And now, therefore, here vertical reaction at each of the outer or inner wheel. Now you will find out the only only one wheel reaction force. So that is the two wheels are getting to be p newtons, but only one point of view p by 2 newtons. So p by 2 equals to how much? C by 2x. C means couple, gyroscopic couple. C is the gyroscopic couple. So C by 2x. That means when you will find out the our gyroscopic couple, then simply to find out the their reaction force also. So that is a very important here. Okay, p by 2 equals to reaction force at each wheel. At each wheel value is the c by 2x. Okay, c by 2x. X means track width. Okay, x means track width. So that is the gyroscopic couple by 2 into track width value. So that is the our reaction forces at the, okay, each wheel. Okay, do you understand up to here? Uh, Anyone respond?
Sir.
Please respond, dear students. Tell me.
Sir.
Tell me, Amma. Tell me your doubt.
Sir, in aeroplanes, is the couple only
Hmm.
applicable for propeller aeroplanes or for both turboprop and turbojet engines? Sir?
Hmm. Okay, aeroplane point of view, only we will consider the what type of plane it is. It doesn't matter. But the thing is,
Okay.
okay, so aeroplane point of view, what are the propellers are there? Those propellers will get the, okay, will get the gyroscopic couple. Okay, so generally now we are observing, okay, generally we'll take in our subject point of view, they may also consider as the only small aeroplanes are there. That means the passengers are traveled only 3 members or 2 members are traveled. So that type of planes will be considered. So that means that is having the only one propeller. Do you observe that? So only less passengers. Which planes are carrying the only 2 members or 3 members? Those planes will be considered here. So the thing is, how many propellers are there? Okay, propeller point of view. So the propellers will make the okay gyroscopic couple here. So if you are taking to be 80 passengers or 100 passengers, then we may have the 2 propellers are there. So but it doesn't matter. But the thing is, those propellers, okay, those places will get the gyroscopic couple. Okay, consideration point of view here, only roadway vehicle point of view, only roadway vehicles will get the particular structure. This one you may also follow the particular. And before the cases and our naval ship point of view and our aeroplanes point of view, only will take the direct formula. So that formula is I omega suffix p. Enough. Okay, I omega suffix p. But here roadway vehicles point of view, four-wheel vehicles, particularly four-wheeled vehicles point of view, so they may also consider the engine parts and our the wheels also, wheel and wheel axis. Okay, so the wheels means those are also one type of okay spinning disc and spinning axis. So that's why they may also consider here, and engine parts are also considered here. Okay, from this you may get that omega suffix w into omega suffix p, that is the 4 into I suffix w plus or minus g into I suffix e. And you may also consider here that is the reactional forces at the outer or inner wheel. So that value is p by 2 equals to c by 2x. Okay, is it clear? Please respond.
Yes, sir.
Okay, now going to this one. Here already completed our gyroscopic couple effect in our four-wheel vehicle. And another effect is there in our four-wheel vehicle. Those are the centrifugal couple. Centrifugal couple effect. Okay, this is the centrifugal couple effect. Before going to find out the centrifugal couple, so all of you observe that. So first we will write the our centrifugal. First we will write the our centrifugal force. So centrifugal force formula already know that is the mv square by r. What is the formula is there? Mv square by r. Mv square by r. Okay, this one we'll discuss in later. Okay, all of you observe up to here. Okay, now the session is going to be over. So anyone raise the doubts? Please raise your
Happy
doubts.
birthday, sir.
Okay, thank you guys.
Sir, happy birthday, sir.
Okay, thank you.
Happy
Thank
birthday,
you.
sir.
birthday, sir.